All right. Good morning and welcome to the third day of the Precision Agriculture edition of Crop Hour. I'm joined by Dr. Jiyul Chang, Senior Lecturer in Department of Agronomy, Horticulture, and Plant Science at South Dakota State University. Dr. Chang brings extensive teaching experience in precision agriculture with a focus on mapping for variable rate applications, remote sensing, and drone technologies. I am Ali Mirza Khan Nafchi, Assistant Professor at SDSU and Precision Agriculture Specialist, and I will be your host today. If you have questions at any point, please drop them in the chat or Q&A at the bottom of your screen. We will address them at the end of the presentation. A quick reminder for those seeking CCA credits, the information will be shared at the very end of this meeting, and we will also post the link in the chat. This session is being recorded and will be posted to our YouTube channel at the SDSU Extension Crop Hour page. With that, I will turn it over to Dr. Chang. Thanks.
Yes. Thank you, Dr. Ali Nafchi. Okay, I'd like to share my screen to maximize my change the laser point like that. Okay, good morning, everyone. Okay, my name is Jiyul Chang, but you can call me Chang. Then today, I like to talk about the drones and the sensors for precision agriculture practice. I'm sure most of you are using drone already, but I like to talk about how to use the drone for the real farm equipment, not just a toy. Okay, so first, there are two different things, platform and the sensors. The drone is a platform. So I'd like to talk about the drone first. Drone has a few different other names, UAV or UAS. UAV stands for Unmanned Aerial Vehicles. UAS stands for Unmanned Aircraft System. Well, those are different names, but actually it's the same one. And then there are two different types of drones, fixed-wing drone and the multi-rotor drone. Fixed-wing drone looks like a real airplane. Multi-rotor looks like a helicopter. So fixed-wing drone is usually we use this one to scan the relatively large field at high altitude, about 400 feet altitude, and it can fly very fast, about 25 or 30 miles per hour. Multi-rotor drone, it can be used for scouting and for the scanning relatively small field at low altitude. So the researchers like to use the multi-rotor drones to scan their study plots. And also, multi-rotor is very good for the spraying and the seeding, especially for the cover crop seedings. And then during the operation, the multi-rotor drones mostly fly in about 10 or 15 miles per hour. It's relatively slow. Yeah, here are the examples of the drones. The first one, this one is a fixed-wing drone. And then this one is the quadcopter multi-rotor drones. Many researchers use this kind of drone because it can have many different types of the payload, like the sensors. And this one very small, the kind of DJI mini one. I know many farmers use this. It's very small, cheap, and then this sensor is very good. This RGB sensor, I talk about this a little bit later, and it's really good for toy and also really good for scouting during the growing season. And this is big. It's a big, the multi-rotor drone called the octacopter drone. This example is about the DJI, the T50. This drone is used for spraying the fertilizers and the herbicide. So these are kind of examples of the drones. Then I'd like to talk about the benefits and the limitation when you use a drone. There are several benefits when you use. The drone using is relatively very flexible because you can fly anytime you want. You can fly anywhere you want, or not just anywhere, but anytime mostly. And you can change the, the payload. You can change the sensors very easily. And it's relatively low cost. Yeah, some drones very expensive, mostly in the about $5,000 or something. And then very high spatial resolution. When you take the images from drone, actually this kind very similar with the cameras in your cell phone. The image is very clear and high spatial resolution, and it's relatively easy to use. And otherwise, there are also several limitations as well. Uh, Drone is very small, so the pretty much unstable platform. So when this wind is pretty high, then you can make the very fuzzy images. And then to scan the large field, you have to take the many images about for example, if you scan the 160-acre field, you have to take about the 600 images. Then to make the big map of the one field, you have to stitch all these small images. Then during this stitching, the geo-rectifying images, the location is maybe not correct. And the third one is many regulations. Okay, I will talk about these regulations a little bit later. And another benefits for on-farm, then is first one is a little to no crop damages. When you drive the inside of field to spray the fertilizer and the herbicide, then your tractor touch the many plant. So it can make the damages in the plant, but when you fly drone, the drone does not touch any the plant physically. And the second one is when you drive the big tractor in the inside of field, big tractor, heavy tractor, and big tires, it makes a very serious soil compactions. But drone doesn't touch the soil, so you can minimize the soil compaction as well. And then next one is you can save the many input cost because we can do the site-specific application very easily from drone. And also, you can use a drone as an additional method of cover crop site-specific seeding. So if we just broadcast the broadcast seeding of the cover crop whole field, we can use a tractor. But if we want to use a different crop, the cover crop seed in the different areas, then you can use a drone very efficiently. So these are benefits. And the next one is about the limitation. Yeah, there are several limitations. First one is a limit by weather conditions. As I mentioned already, the drone is a relatively small platform. So if the wind speed is very high, then it's very unstable. So usually we do not recommend when the wind speed is greater than 20 miles per hour. So it is not safe. And also we cannot fly drone in fog or rain because drone is not the water protect one. Okay, so weather is one of the big limitation. And next one is the battery. Some drone is operated by gas, but most of drone operate by the batteries. But battery does not last very long. It's about 10 or 20 minutes. If the payload is very heavy, then the flying time is very reduced. So battery is one of the limiting factor when you fly drone. So if you want to fly drone, the use of drone for the relatively big field, you have to prepare the 2 or 3 different separate the extra batteries. And also battery charging is getting faster, but it still has some minutes. Minutes or half hour or something. And then to use the drones, you need to get the training for the drone operation and the image processing and analysis. Actually, drone operation is relatively easy. You can get maybe half day training, that's okay. But for the image processing and analysis, you need a little bit long trainings. Initial cost, yeah, somebody said, okay, the draw is too expensive, the sensor is too expensive. Yeah, that's okay. Then the next one is many regulations. This is really big issues when you use a drone. Regulations by FAA. There are many regulations. So to fly drone, to use the drone for farming, you need to get the couple of the pilot certificate. And then this, beyond the visual line of sight, BVLOS. This is one of the very big limiting factor. That means the pilot should see the drone all the time. If the drone is out of sight of a pilot, it is illegal. Altitude, ultra-altitude airspace is one of the big reasons as well, because it does not conflict with the real airplane airspace, because it is really dangerous. And do not operate over the people and the vehicles in the public areas. Do not operate the drone during the night. Then you have to do the registration, and you have to limit the weight. I like to see the more detailed things about regulations. Actually, the primary operator, the pilot should require FAA-approved remote pilot license. We call this Part 107. So Part 107 required for drone for farming and drone for research. Any kind of operation related with business or money, you have to get this Part 107 pilot license. But if you want to fly drone for hobby, then that's okay. You don't need this. But you collect the data, and the data is related to your business, farming business. You'd have to have a Part 107 license. And second thing is flight must not be VVLOS. Drone should be operated during daylight only, and the drone should not be flown in the public area and near airport. These are very restricted limitation. But if you want to do this, you can submit your petition form on FAA website. Then you can get some permission. Next one is the drone must remain below in the 400-foot commercial airspace ceiling. Yep, there's 400 is the maximum the altitude when you fly drone, and must not fly faster than 45 knots. And the drones that cannot be flown within the 500 feet of any person's personal areas. So if you want to do this, you have to give a notice to the person, and you have to get the protective equipment. And the next one is about for the spray drone only. If we want to use a drone to spray the chemicals, like the fertilizer and then the pesticide, you have to have a Part 137 certificate. Basically, this certificate to design to ensure that the area operation involving in the application of agricultural input, like the chemicals. If we want to get more information about the Part 137, then please go to this link. Okay, these are about the drone things, the platform things. Okay, next one is I like to talk about just a little bit basic science about the remote sensing things. Because the main reason of using drone is we need to collect the data. So to collect the data, we need a sensor, and the sensor I like to talk about a little bit basic science about the sensors. To understand sensor, we need to know these things. Electromagnetic spectrum is electromagnetic spectrum is like just a light. It's simply you can say light. The actual wavelength of the light is very wide ranges, 10 to the negative 14th to 10 to the 4th, so very wide ranges. but most of the light human eyes cannot detect that or cannot see that. Human eyes can see only very narrow ranges of light, like this, only 400 to the 700. Between 400 to 500, we call this blue color ranges. Between 500 to 600, we call this green color ranges. Between 600 to 700 nanometer ranges, we call these red color ranges. Human eye can see only this blue, green, red. So we call this blue, green, red is the basic, the light colors, basic blue, green, red. But this red edge and the near infrared are very important wavelengths for agriculture. Red edge and the near infrared. Yeah, we'll talk about this later. Then when you go to the field during the growing season, you can see the corn plant and the soybean plant. What is the color of the corn plant and soybean plant? All those are green. If that's healthy, all those are green. Why the human eye see the corn plant and soybean plant are green colors? The reason is this. Human eye can see blue, green, red only, but plant use the blue color and red color light for photosynthesis, but green color doesn't. So plant reflect all green color because the plant does not need green color. So human eye can detect the reflected light only like the green. But the main idea is there. Same thing, so blue color, human eye, if the object is blue color, that means only blue color is reflected from the object. Green is the same, red is the same. If the object reflects all light, all visible light, is a white color. If the object absorbs all visible light, that is a black color. So that's the main idea, main background of the science of the remote sensing. Then now, why we can use this one remote sensing stuff for the agriculture? Because of this one. This is a dissection of the plant leaf. This is a top layer, this bottom layer, and then this is the layers. Then in this, we call this palisade mesophyll layer. This palisade mesophyll layer contains the chloroplast. Chloroplast is the work for the photosynthesis. So chloroplast absorbed, use red color and blue color for photosynthesis. But the chloroplast does not need green one. The green color is reflected by the plant. And then second layer, sponge mesophyll layer is totally different. Sponge mesophyll layer is big cell, and most of these cells contain the waters. So if the plant is healthy, all the cells is filled by the water and very tight. At that time, near infrared, this kind of cell reflect near infrared a lot. But plants are under stress. First symptom is the sponge mesophyll layer cells, they lose the water. Then there is a squeeze. Then the reflectance of near infrared is very small, reduced a lot. Because of this reason, we can use a near infrared to identify healthy plant and unhealthy plant. So it's like that. This is a spectral, the signature of the healthy plant, unhealthy plant. This blue, green, red edge in the near infrared. And then like this, healthy plant, and then there's observe the blue and red or lot, so it's a very low reflectance. But in the near infrared areas, healthy plant is a very high reflectance values, more than this stress plant. Because of these big differences, we can identify the healthy plant, unhealthy plant very easily. Red edge, I'll talk about the red edge a little bit later. Yeah, so we call this a spectral fingerprint. This one is a typical curve of the plant. The different objects have different curves. So we call this a spectral fingerprint. The next one, this is basic of the remote sensing. Then to detect this kind of things, we need the sensors. Sensors are same with the human eyes. So there are many different types of the sensors. Okay, this one is an example is a multispectral sensor by Centera. There are two lenses, but there's a 5 band. And this one is example of the microsense red edge. The MX sensor is also a multispectral sensor. 1, 2, 3, 4, 5 different sensors, lenses. And this one is a hyperspectral sensor and the LiDAR sensor. The round shape one is a LiDAR sensor. LiDAR sensor is measuring the distance or elevation. And the box shape with the bottom one is a hyperspectral sensor. And this one is a thermal sensor. Thermal means heat. But this sensor detects the heat of the soil or heat of the plant. I will talk about this just next slide. Okay, sensors for what kind of sensor you can use for precision ag. First one is multispectral sensor. Multispectral sensor, there are first one, the most basic one is RGB band. This one is the same thing with the camera in your cell phone. Okay? So my cell phone, when you took your selfie or you take the pictures of the corn plants yourself to your cell phone, there's exactly the same thing. RGB band, RGB kind of sensor can make the natural color images, and these are good for field scouting, and then it's good for the stand counts. Next one is a near infrared band. I talked about this in the previous slide. Near infrared is very, very useful in the agriculture because it's very sensitive to the sponge mesophyll layer. And when you use, we need a near infrared band to make the NDVI. NDVI, I talk about this more detail in the next slide. And red edge is a very sharp, the curve between red and the near infrared. This red edge is very sensitive chlorophyll content, and we can make the NDRE index. Yeah, I talk about this more detail also next slide as well. Okay, next one is a hyperspectral sensor. The multispectral sensor is mostly in the 3-band, 4-band, 5-band, 6-band, or something like that. But hyperspectral sensor has a 300 narrow bands. And that it can be used to make the target specific indices. And then this one is not easy to use, so most researchers use their own. And then from this 300 narrow band, they try to find a certain band for the certain target issues. Select this band from the multispectral sensor, and then make the hyperspectral and make the multispectral sensor based on their finding. So that hyperspectral sensor is mostly good for the research, for the work. Thermal sensor, as I mentioned, this sensor measures the heat from the soil, heat of the plant. So when the plant is under stress, they lose the waters. That means the temperature of plant body biomass increase. That means the thermal sensor value means the plant is under stress. Also, soil is same. If the dry soil is very hot, then now the wet soil is the low temperature. So also that can be used for irrigation schedules. So the thermal sensor is very, very useful for farming. Last one is a LiDAR sensor. Okay, LiDAR sensor is the kind of laser. It's a laser. They shoot the laser from the sensor and measure the reflected laser. So it's very, very fine data set. And you can measure the distance or you can measure the height of the crop plant or height of buildings. To provide the elevation and height of object and estimate the crop production, because based on the researches, the height of the biomass is a highly positively related with the crop production. And we can differentiate the variety as a hybrid of crop plant. Okay, even though it's the same NDVI, the different variety of different hybrids at different height. So when you use a LiDAR sensor, we can differentiate the different hybrid and different varieties very easily. And we can make the also landscape map. So this is about the sensors. Okay, then whenever you scan the area, the soil field using the sensors, you need to calibrate. So whenever you fly the drone, you need to use this kind of calibration panel. Then now in the post-processing, you need to use this reflected data to calibrate your images. Okay, those are about the sensors. The next one, I like to talk about the spectral indices like the NDVI and NDRE, because the many farmers in the agriculture, we do not use a single band of images. We use the index maps, index values, because index is a mathematical equation to reduce the multi-band observations. If you want to use a single band images, you need to use maybe 2, 3, or 5 number of band values. But if you use the equation to combine all these different bands, we can make only one number from the 2 or 3 different bands. We call this index. So index is very, very useful for using, and also the index numbers are to maximize the sensitivity of a certain object. For example, in the NDVI is very, very sensitive to the mesophyll layer in the plant in the plant leaves. NDRE is very, very sensitive to the chlorophyll content in the plant, something like that. So NDVI, the equation of NDVI is NIR minus red over NIR plus red. Equation of NDRE is NIR minus red edge over NIR plus red edge. These are very similar. NIR, we use NIR for both index. We just switch the red to the red edge. So that means near infrared is the most useful band in agriculture. So again, like this, near infrared is very sensitive to the spongy mesophyll layer, that we can identify the stressed plant and the non-stressed plant very easily. So I'll talk about the NDVI just a little bit detail. NDVI is one of the most successful tools in agriculture. The NDVI, this kind of one, captured by satellite and drone images. And then to do NDVI, we need to do 2 bands, red band and then near infrared band. Mostly in the red one is this. Yeah. So NDVI, mostly in the plant, has plant observe the blue and red and reflect the green light. And the plant also reflects near infrared a lot. But unfortunately, human eye cannot see the near infrared light. Human eye cannot see. But anyway, health plant and the more near infrared light reflected. So this example of the reflectance of the dead leaf, stress leaf, healthy leaf. I don't care about the dead leaf because human eye can find out the dead leaf very easily. But the problem is this one, stress leaf. When you look at the reflectance pattern of the blue, green, red of a stress leaf and the blue, green, red of the healthy leaf are almost the same. If those are same, human eye cannot separate these two. Human eye do not know this plant is under stress or not. But when you use a sensor to detect near infrared like that, the reflectance of near infrared on the stress leaf is very small, very low. But reflectance of near infrared on the healthy leaf is very high. So if we need to use a sensor to detect these things, and it is very, very useful. Okay, so benefit of NDVI is first, we can identify the problem sooner. How soon? About 2 weeks before human eye can see. If the human eye, if a human eye see, okay, this plant has a problem, then maybe too late to do something. But if I find out these problems or issues maybe 2 weeks before the human eye can see, we can recover, and we can solve the problem. So these are really, really important things. Second one, you can scout the field faster. Yeah, if you scan the whole field, using the drones and the satellite images and make the NDVI map, we can see the healthiness of the plant in the one big field at once very easily. Track crop health. Yeah, if you take the NDVI images periodically during the growing season, you can track your health plant very easily. Create very rate prescription map. Yeah, NDVI is a very good the base map, the management zone map, to make the variable rate nitrogen application map during the growing season. And also you can estimate the crop production. Yes, right. NDVI value is a very highly, almost the 90%, highly related with crop production positively. Then also there are some limitations of NDVI. So limitation is we cannot saturate. It can be saturated the crop stage, late crop stage, like the end of July or the beginning of August. That's very peak time. There's very plants are very green. And now maybe the NDVI values can be saturated. Then if these values are saturated, that means differentiation is not possible. So that's one limitation of NDVI. So we can overcome this kind of the problems. We can use NDRE, normalized difference red edge index. So equation like that, red edge one. So red edge is very sensitive to the chlorophyll content, so we can estimate the nitrogen uptake, plant vigor, and the stress detections. So to calculate NDVI, we need this near infrared and red edge instead of red band. Red edge the sharp, the increasing areas. So NDRE is very sensitive to the chlorophyll, and then the red edge there is a 607, but red edge band is 670 to 760. It's a little bit longer than the red. So it is not but health plant have more chlorophyll and observed more the light in the red edge band. So stress plants have a stronger reflectance than the health plant in these areas. The red edge is pretty useful. And then the red edge band is not the strong PAR. PAR stands for photosynthetically active radiation. That means chlorophyll use this light for the photosynthesis, but it's still sensitive in the chlorophyll. So it's very useful, and also it can translate the plant deep. So NDVI measures only surface of crop, but NDRE can measure a little deeper. So we need in the end of the growing season, and then NDRE can be more differentiated. And so if we use the NDVI and the NDRE together, then we can make the better decisions. Okay, the last topic is about the drones for farming. We can apply the drone for precision agriculture. There are two categories: collecting data and the site-specific spraying. First one, to collect the data, you can scan and the scouting and the sand count, and for site-specific spraying for the fertilizer, pesticide, and the seed, especially for the cover crops. Then to do this, we have two different types of the flying: planned flying or mission flying, and manual flying. Planned flying is we need to make the fixed wing drone and multi-rotor drone can be used for this. You can make the flight plan on the computer in the app, then upload this flight plan. Then now the drone followed all this the flight plan automatically. So it's kind of the automatic the flying. Then scan large, this good for the scan large field to monitor plant healthiness and the crop production. And also that's good for the site-specific spraying and the stand count, because we need to fly in the consistently same speed, and then the do not overlap the same areas. Second is manual flying. Manual flying is this. Just you use the controller joystick to control your drone. So only multi-rotor drone is available for the manual flying. We cannot do the manual flying with the fixed wing drone. We cannot, because it's very dangerous. And this one, manual flying, is good for the scouting field and plant conditions. It's less scouting. So I know many farmers use this one. Drone use in the spring. I like to talk about the spring just a little bit. To spray the fertilizer and the chemicals and the seed from the drone, we have to use a multi-rotor drone, and it must be the mission fly, okay, because we need to spray in the exact locations. And then there are two different ways. We upload the flight plan, then now wherever to do the variable rate application and the site-specific application, followed by prepared map. So if you have a map, you can make the map by the drone and by the satellite. They upload the map into the drone, and the drone follow the map, the flight plan to do the variable rate application and the site-specific application as well. And the second one is a see and spray operation by AI. So right now, it's the controller computer, it support the AI, the information to the controller in the drone. Then drone, fly in the top of the crop field, and detect the plant. And if the plant has kind of problems, and maybe it's not healthy, we have to spray the fertilizer, or the drone detect the weed, you have to spray the herbicide. So the see and spray the technologies. And to do this also, again, you need to do the Part 107 pilot license, or the Part 137, the agriculture aircraft operation certificate as well. Okay, here's examples of the spray drones. And then spray drones is very huge. It's very big one. So I put the link. There are 3 links that are very, very useful to search about the spray drone. So you can look at this later. Operations. Then is for application rate of spray drone to a low crop is like the 1.2 to the 2 gallons per acre. It depends on these things. And the maximum flying speed is 10 to 20 miles per hour. And this is very important. The 10 to 12 feet above from the ground or crop canopy. If there's a fly too high, there are too many distance, too big, the large distance between crop surface and this, there's all these, you can spread all different areas. There's uncertain, non-target spraying. And then this one is kind of from the magazine. Okay. The Rentizo is the name of company for the spray drone in the Iowa-based company. Then they got some permission from the FAA about this. Swarm up to 3 drones without a visual observer and at night. That means mostly based on the FAA regulation, 1 pilot can control only 1 drone. But this company can get the 1 pilot control up to 3 drones. And then without visual observer, that means the pilot can fly drone, BVLOS, the beyond the visual line of sight, and also at night. So these 3, the petition is really, really important for the drone business. Then when you use the spray drone, there are advantages and disadvantages. The first advantage is this. avoid soil compaction, as mentioned already, plant damages, broadcasting site-specific application, and deep penetration. Deep penetration. So sprayed from the top, and then the propellers disturb the plant a little bit, then the chemicals can penetrate a little deeper. Disadvantages is a possible off-target drift. Yeah, this is off-target drift. So if the flight is too high, you have a lot of off-target drift. So you have to avoid off-target drift. And it depends on whether it's too windy, you cannot do this, and not go for the very large field. So if you have maybe I have extra batteries, 5 or 6 batteries, yeah, that's okay. Then you can just change the batteries. But the price of battery is pretty expensive, and the recharging the battery takes a long time. So battery is still kind of limitation factors. Okay, this is all the topics what I want to say today. So I hope this helps you for the farming actions. If you have any questions, then you can contact me in this one, in this email address, or you can submit your questions in this website. Not the website, here in the question Q&A. Okay, then I like to stop sharing the screen, and then
Thank you, Dr. Chang.
yeah, and the next speaker, we have 20 more minutes. Next speaker is Dr. Ali Nafchi. I'd like to introduce Dr. Ali Nafchi. He is an assistant professor at SDSU and the Prison Agriculture Extension Specialist. In his digital lab at SDSU, he runs applied research and extension programs focused on the innovative technologies, sensor and data-driven and site-specific fertilizer management, and also helping the producers to make the better and more profitable decisions. Okay.
Thank you,
Please
Dr.
welcome
Chang,
Dr.
for the
Ali Nafchi.
introduction. Thank you. Thank you very much for excellent presentation. So we are focusing on how drones support South Dakota agriculture with a practical mindset. I echo what Dr. Chang presented. There are two categories: imagery missions that help you scout, document, and monitor conditions, and application drones that can spray or broadcast seed or fertilizer in targeted scenarios. The objective is a repeatable workflow we can run in a real farm condition, plan the mission around a decision, fly safely and legally. This is very important. Collect usable data, quality check, interpret with ground truth, and deliver a product that a farmer or advisor or researcher can actually use. Drones are very valuable when they shorten the decision cycle, especially in South Dakota, where wind, weather shifts, and short windows can force fast choices. So I will shorten because Dr. Chang covered everything here, but I will touch base some of the different differences between satellite imagery and UAVs, and how drones are going to help us to see more details. Think of farm information as layers. Satellite imagery provides broad coverage and very frequent revisit. Some of them are free. The resolution and clouds can limit what you can reliably interpret at the field scale. Boots on ground are needed for both of them, even for drones. And I want to just look at this image as I am changing and going deeper into resolution. So with drone, you can go with very high resolution compared to the satellite is now we use Sentinel satellite that is 10 by 10 meters pixel size. We have, this is free, but we have Planet, which is you have to have pay for that, comes with cost. If you look the same field, but the date is little different. So this is what we can see for drone. You can go on demand, but for satellite imagery, you get it more frequent. But the point is, some of them you can use. So June 16, we could go and fly, but on June 16, because of the cloud, we didn't have satellite image. Now, if you look, we have more details in drone RGB and NDVI maps. And if you compare the NDVI with NDVI of drone and satellite, you will see the differences here. How close, how high resolution we can go with drone compared to when we get to a point of 1 pixel of satellite, you see only one color. And that is representing that pixel. So the drone success mostly comes from process discipline, not the most expensive platform. The chain looks like define the decision, plan the mission, sitting around that decision, capture consistent images or data, and process into usable product. Later, we can interpret the patterns with ground truth, then decide and document. So if we break any of these lines, we will be at risk. So we can fly and collect great looking data or images, but if we skip ground truth or validation or confirmation, we may get confused by different symptoms. For example, compaction with nutrient deficiencies or stress. The point is to treat drone work like field agronomy, set a purpose, take notes and document it, validate it, and produce a clear expectation. In applied drone work, the chain is higher stake because we are working with chemical and application, and is more. So now again, if you look at the pixel size, which I showed you in the last slide, with satellite imagery, we could see just one color, whereas with drone imagery, we can go deep and see, if we go with very high resolution, we can see half an inch. And with that, we are able to detect and diagnose some diseases. And so drone support decision, this is obvious for us that we can translate drone into real farm decision. Early in the season, drone support uniformity and stand assessment, helping diagnose planting issues, residue effects, and wet spots that create gaps or ups and down and fluctuation in emergence. Mid-season drone support, mid-season drone support with scouting, variabilities, drainage pattern detection, basically on demand, right after when we get rain, and we can detect insects and disease suspicion, and followed by, of course, field confirmation. In late season, The drone can document lodging assessment, storm damage mapping, and documentation for insurance or internal management reviews. And the important point is the output. A good drone product is not, it is a list of what to do or action list for to making decision. And if we do it right, the return on investment for drone is really meaningful and is high. What drones don't do well? So setting expectation protects your credibility. Drones do not automatically diagnose plant problems. They show differences in canopy, vigor, color, texture, but they cannot tell you whether the cause is nutrient deficiencies, compaction, disease. They cannot tell. We have to work on it and find out what are the problems. Drones also don't remove the need for crop advisor agronomy knowledge. They amplify it. They help. So another limitation is weather sensitivity. Wind creates motion blur and stitching errors, and inconsistent sunlight changes the reflectance and can distort comparisons across the dates and the data. Finally, drones don't automatically produce useful products. Most growers don't need to have lots of layers or indices. As Dr. Chang mentioned, NDVI will help a lot. They need a clear summary of what's happening, how many acres are affected, and assess and help to as a strong decision support layer rather than turning drone into a map making tool. Application drones are fundamentally different from imaging drones because they dispense material, liquid product, or broadcast solid products, seeds or fertilizer. The value proposition is strong in certain environment, like tight timing windows, wet fields, and we have, especially for cover cropping system, when in short cold season in South Dakota, if we want to have establishing cover crops in standing corn, we can go and at the end when we are sure the maturity happened, means we are getting close and we have to wait from the maturity to the harvest time. Drones can help to apply or broadcast your cover crop seeds. The weed module is another application, so we can assess. We have a system now we are using that see and spray. So we hotspot flight work best when weeds are detectable from above and when the result still allow action. If we fly too early and weeds may be too small, we cannot detect them, or they are masked by residue. And if we are too late, then the control of the weeds at higher stage is difficult. So timing is a point. For that reason, again, satellite imagery can help. And frankly, in the future, I can see that AI with automatic robots, always assessing with any existing satellite or sensor, or and they will make a platform and timetable for drone best practice for drone flights. So drone can assess the damage. Damage assessment flights are high return on investment as documentation. The evidence package includes date, stamped aerial overview of the whole field, closing images and representative severe zones, annotated maps showing affected area, what's the level, and again, if we go and ground truth it with photos, with location, that we can confirm that image is related to this level of the damage. This is valuable for insurance and internal planning. Drones can show lodging extent, defoliation pattern, and lots of things that, frankly, if we go to our field, we cannot go and see every point, but with drone, we can get a good picture, a big picture of what's going on in our field. So another topic I wanted to talk here, we developed virtual yield mapping system, and with that, in that virtual mapping system, we have total bushel harvested. Everybody has this number, and we developed the algorithm. If we distribute this total bushel harvested based on this algorithm, you will have yield map. So this is great for those who don't have the yield monitoring system, or we can go back and have these images, of course, with satellite, and because we cannot go and have it with drone, and have yield map. So it will improve the accuracy of the yield maps created or generated by yield monitors is sometimes more accurate. Now, I want to show here what we'll see. Satellite, so we use Sentinel, show field scale vigor and pixels, but with drone, you can go and have small pixel, and if we average, let's say, 3 feet by 3 feet, then we will have the yield pixel for that 3 feet by 3 feet. And imagine the one number we have from the combine is that number, the strip or the cutting bar or the head of the combine, you will get one number regardless this side of the head. You have very high yield, this one is low yield. It will average it and it will go one number across the head of the combine. Think about it, in a set of having 60 foot, 60 or 70 or 40 feet long, just one number, you will have 3 feet by 3 feet. And that will help a lot for researchers especially. So another topic we are working is biosensor rich spot, that we can assess the needs of nitrogen. Yesterday I talked about it. You can go to YouTube channel and watch that one. Drone are going to be great asset to do that. We can do that one with satellite imagery, but drone will help more with more accuracy. And so we develop here at SDSU the next generation imagery. We call it 360 pics, plant image capturing system, that it would collect lots of more image than only the top view. So we will have all around and with different angle to see deeper inside the canopy. With that, because I am short in time, thank you very much again. And if you have any question, I will answer your question. Thanks again. I do not see any question here. Yeah, please type your questions, or I think you can unmute and ask your question from me or Dr. Chang. We will try to answer your questions. One more thing I can add is please reach out. We would love to work with you. We are team, Dr. Chang and I will work, to serve South Dakotan farmers and crop advisors. We would love to host you here in Christian Ag at the building at South Dakota State University. And there is a question here, Dr. Chang. Is there an easy way to access the free satellite imagery in season? This is for me, Dr. Chang. Yes, I have a fact sheet on our extension website. As I explain step by step, even if you don't have any background in computer, you can go there and follow that fact sheet. You will get that free satellite imagery in season. That Sentinel, it was every 3 days, now is every 2 days. Finally, it will get to the point you will have every day satellite imagery, 10 meters by 10 meters. Thank you. It was great question.
You have one in the Q&A. Any AI programs you have tested for stitching field images, if one of you wants to answer that?
Sure. Should I go or Dr. Chang?
Yeah, maybe I can answer this. Yeah, to stitch the images, the drone images, we need a certain software or app. Then, yeah, these are basically the software's app is operated by AI, the many things. But the easiest way is if you download the drone deploy app. There's a free app, but if you need to pay some money to upload and download the images, drone images from the cloud of the drone deploy, then if you pay some money and upload all your drone images on the server cloud of the drone deploy, and they stitch the all images and make the NDVI map as well. And you can download the images from the cloud server. That is the easiest way.
Thank you, Dr. Chang. Is there any other questions? I see none. So thank you very much again. Thanks, Dr. Chang and Sarah. And thanks you all. And we'll see you next week for other crop hour. And this will be recorded and posted on our YouTube channel. Please reach out and see you next week.
Thank you, Sarah and Ali, and have a good day, everyone. Bye.
Thank you.